Welcome to the session. In this session, we are going to discuss about inode structure and how to establish link between the files, means ln command. Next, types of links, means hard links and soft links, how to establish hard link and how to establish soft link. Okay, so all these topics we are going to discuss today. Okay, so in the previous session we already know how to view the attributes of a file, means by using ls space -l command we can view the output in 7 columns, means it is going to distribute the attributes of a file. In the first column it is going to display the file permissions, in the second column it is going to display the link information, and in the third column it is going to display user identification details, and in the fourth column it is going to display group identification, and in the fifth column it is going to display the file size in bytes, and in the sixth column it is going to display the date and time of file creation, and in the last column it is going to display the file name. Okay, so by using ls space -l command we can view the attributes of a file. Okay, today we are going to discuss about inode structure. Okay, this inode number can also be seen by using ls space -li command. Okay, so inode number is created for each and every file. As soon as the file is created, kernel allocates a unique identification number to a file. Okay, whenever a file is created, kernel allocates a unique identification number. Okay, already we discussed about what do you mean by an inode in types of files. Actually, directory files contains the file name and file identification number. Okay, today we are going to discuss about the structure of an inode. Okay. Observe the structure. Here the inode structure contains file type. Okay, so means the created one is either a file or a directory. Next, link information. Okay, whether a created file is linked to any other file or not. Okay, and user identification of owner, means UID of owner. Next, group identification of the owner, and access time, means file access time, file modification time, and the time the inode was last created, generation of an inode number, and address of first 10 blocks and of 3 indirect blocks. This is the entire structure of an inode. Okay. So as soon as the file is created, kernel is going to allocate a unique identification number to a file. Okay, so an inode number is a positive integer, means it depends upon the number of inodes available in a file system. Okay, so inode number is a positive integer. Then this positive integer depends upon the number of inodes that are available in a total number of inodes available in a file system. Okay, inode stands for index node. Okay, these numbers are called inode numbers, file identification numbers. These are used to access any required specific inode structure. These inode structures are maintained in the form of an array. Okay, so all these are housed in a separate block called inode block in a secondary storage area. Okay, so whenever a file is created, kernel allocates a unique identification number to a file. Okay, so these numbers are called inode numbers. These inode numbers are used to access a specific inode structure. These inode structures are maintained in an array. These inode structures are available in inode block in secondary storage area. Okay, so all these are maintained in an inode block. Okay, this point you have to remember, where in the secondary storage area. Okay, so inode stands for index node. These numbers are called inode numbers. Okay, all this information will be available in directory file. Okay, so directory file contains the information about file name and file identification number. These file identification numbers or inode numbers are used to access required inode structure. Inode structures are maintained in the form of an array. These are maintained in a separate separate block in secondary storage area. That block is known as inode block. Okay, this is inode block in secondary storage area. These are used to access inode structures. Okay, inode stands for index node. Whenever a file is created, kernel is going to allocate a unique identification number to that file. Okay, this inode number is a positive integer. Okay, positive integer. It depends upon the total number of inodes that are available in the file system. Okay. Next, all the inode structures are put together in the form of an array in inode block on the secondary storage area. Okay, now by using ls-l command, we can view the link information, file permissions, user identification number, group identification number, file size in bytes, date and time of file creation, and file name or directory name. Okay, so by using ls-li command, we can view the inode number of the created file. Okay, so the syntax is ls space hyphen I space file name in order to view the inode number of a specific file. ls space hyphen I space file name. Okay, so ls space hyphen I command takes one file name as an argument. Okay. Example is ls space hyphen I space sample. Here sample is the file name. Okay, so it is going to give the inode number 1375 for sample file. Okay, it doesn't display the remaining attributes of sample file. Okay, ls space hyphen I command display only the inode number of specific file. Here I specified sample as my file name. Okay, so then it is going to display the inode number of this sample file only. In order to view the all attributes of a file, sample file, then we have to issue a command ls space hyphen li. Okay, this is a new command. Okay, actually we already discussed about ls space hyphen l command. Okay, by using ls space hyphen l command, it is going to display the attributes of all files that are available in our current working directory. In order to view the specific files, specific file attributes, we have to specify the file names as an argument to ls space hyphen l command. ls space hyphen l space file name 1 space file name 2 space file name 3. Like that we can specify the multiple file names as an argument to ls space hyphen l command to view the attributes of those specific files. Okay, so ls space hyphen l command can work either with argument or without argument. Okay, one more command is ls space hyphen li. Okay, in order to view only inode number, the command is ls space hyphen I space file name. It displays only inode number and file name. Okay, whereas ls space hyphen li space file name, it is going to display all 8 attributes of specific file. Okay, all 8 attributes means it also displays the inode number. ls space hyphen l displays 7 attributes of a specific file. ls space hyphen li command displays all 8 attributes of a specific file. Okay, actually in the first column it is going to display the inode number. Remaining all attributes are same as ls space hyphen l command. Okay, ls space hyphen l command displays the attributes from file permission to last file name. Okay, whereas ls space hyphen li command displays inode number to file name. Okay, so in the first column it is going to display inode number, that you have to remember. Okay, so ls space hyphen li command displays all 8 attributes of a specific file. Okay, so 1375 is inode number, next hyphen or w hyphen or hyphen hyphen or hyphen hyphen, default permissions of a specific file. Here the created one is sample is a file. That's why first character is specified by using hyphen. Okay, next in the third column it is going to display link information. Fourth column it is going to display user identification. Okay, next in the fifth column it is going to display group identification. In the sixth column it is going to display file size in bytes. In the seventh column it is going to display date and time of file creation, and in the last column, it is eighth column, it is going to display the file name. Okay, so by using ls space hyphen li command, we can view all 8 attributes of a file. This is about ls space hyphen li command. If we specify ls space hyphen I space file name, means it gives only the inode number and file name, whereas ls space hyphen li command gives all 8 attributes of a specific file. Okay, this is about ls space hyphen li. Okay, a file can have more than one name. The next topic is file names. Actually, a file can have more than one name. Why we are using multiple names for a single file means in order to provide security for the data. For example, if multiple person or different persons from different working locations work on the same file, then it is difficult to use with the same file name. Okay, so these different persons can specify their own names for the same file in order to provide the security for the data that is available in a specific file. So a file can contain more than one name in order to provide the security. Okay, so we are going to discuss about file links. Why do we establish a link between the files, and what are the types of links that are available in Unix? Okay, so all this we are going to discuss now. Okay, so a file can have more than one name, and the reason is to have multiple file names is that of security. Why we are giving multiple names to a single file means in order to provide security, we are giving multiple names to a single file. For example, if we take an employee file in an organization, multiple departments can work on the file with their own names. Okay, for example, if accidentally one file is removed, the same file with multiple names are available now, so remaining files will be available, so the persons can work on the file. This is the main importance of maintaining multiple names for a single file. Mainly security. In order to provide security, we are giving multiple names to a single file. Okay, so if a file has multiple names and if accidentally one file is removed, remaining files with different name will be available. Okay, another reason is to have multiple file names is in situations where different persons from different working locations can work on the same file with different file name. Okay, next. File links are of two types. Okay, links are of two types. One is hard link and the other one is soft link. Okay, hard link and soft link. In Unix, more than one user can use the same file with his or her own name. Why we are establishing multiple, why we are giving multiple names to a single file means in order to provide security, we are giving multiple names to a single file because different persons will work on the same file. Okay, it is difficult. That's why we are giving multiple names to a single file. Means the content is same, file names are different. Therefore, the multiple persons can work on the same file with their own name. Okay, so in Unix, more than one user can use the same file with his or her own name. Okay, if a file has two names means the link information will be 2. Actually, this link information will be available in the second column. If we specify ls space -l command, it is going to display the link information in second column. Whereas if we specify ls space hyphen li command, it is going to display the link information in the third column. That is the main difference we have to remember here. If we specify ls space hyphen l command, it is going to display the link information in the second column. Whereas ls space hyphen li command displays the link information in the third column. Okay, because it is going to display the output in a 8 column format. Whereas ls space hyphen l command displays the output in a 7 column format. Okay. So a new file name can be linked to an existing file name. Okay, new file can be linked to an existing file, and in turn linked to a physical file on the disk. In turn linked to a physical file on the disk. A new file name can be linked to an existing file name. New file name can be linked to an existing file name. Okay, and in turn linked to a physical file on the disk. Okay, using the ln command. Okay, ln stands for here link. Okay, if trial is an existing file, here I created two files. One is trial file and the other one is test file. Two files, trial file and test file. Okay, trial is an existing file and test is a new file. Okay, now I am going to establish link between trial file and test file. Okay, for this one the syntax is ln space first file name space second file name. Then this command is going to establish a link between the two files. Okay, trial is an existing file and test is a new file. Okay, observe the syntax. ln space file name 1 space file name 2. Okay, here file name 1 means this is an existing file. File name 2 means new file. Here you are establishing link between the existing file and the new file by using the ln command. This is about a hard link. Okay, so ln space trial is an existing file name and test is a new file name. Okay, ln space trial space test. The trial and test are the files. Okay, so here I established a link between trial and test. This command doesn't display any output, just establishes link between the trial and test files. Okay, in order to view the link information, once again we have to issue a command ls space hyphen li command or ls space hyphen l command. The difference is ls space hyphen l command displays the output in 7 columns. In the second column it is going to display the link information. It doesn't display any inode number. Okay, whereas ls space hyphen li command displays the inode number also. It's better to issue ls space hyphen li space trial space test. Okay, now we can view all 8 attributes of trial and test files. Okay, so by using this command we can view the link information and all attributes of this trial and test files. Okay, ls space hyphen li space trial space test. We have to separate the file names by using spaces only. Okay, so li means l means it is going to display 7 attributes. If we specify I, it is going to display an inode number in the first column only. Here we have to observe the inode numbers of these two files will be same. This point you have to remember. Okay, after executing this command, we have to observe the inode numbers of two files. The inode numbers of these two files will be same. Similarly, here trial is linked to test, means here link is established between these two files. So then it is going to display the link information as 2. Means here two files are linked. It is going to provide the link information as 2. These 2 points you have to check. Okay, after establishing a link between these two trial and test files, we can view the output of this command by typing ls space hyphen li space trial space test. trial is an existing file and test is a new file. In the first column it is going to display the inode number, and in the third column it is going to display the link information. Okay, so whenever hard link is established between two files, we have to check whether the inode numbers of these two files are same or not, and the link information is true or not. If these two files are linked, then it is going to display the link information as 2. Okay, these 2 points we have to check after establishing a link. Okay, so the link value 2 indicates that the file has 2 links. Okay, between trial and test, link is established. Okay, the 2 limitations of these hard links are, we cannot link directories. Okay, directories cannot be linked. This point you have to remember. And files across 2 different file systems cannot be linked. Okay, means two created files are same files. For example, two created files are C files or Java files or Python files, whatever it may be. Okay, but 2 files should be same. Okay, 2 files should be text files, or 2 files should be C program files, or 2 files should be Python files. Like that, 2 files should be same. Okay, this is about how to establish hard link. Okay, so syntax is ln space first file name space second file name. First file name is an existing file name, and the second file name is new file name. Okay, so command is ln space trial space here test, because I created these 2 files. This command doesn't display any output. In order to view the output of this command, we have to issue a command ls space hyphen li space trial space test. Okay, after executing this command, 2 points you have to check whether the 2 files inode numbers are same or not. These 2 are same or not. You have to check. Similarly, you have to check the link information. After a file is created, by default it is going to display the link information as 1 only. Okay, after establishing the link, you have to check whether the link information is 2 or not. Okay, here these 2 files are linked. That's why it displays 2 as link information. Okay. In the first column, we have to check inode number, and in the third column, we are going to check link information. Okay, so directories cannot be linked, and files across 2 different file systems cannot be linked. These 2 points you have to remember. Okay. Next one is soft links. Okay. Soft links are also called as symbolic links. This point you have to remember. Soft links are also known as symbolic links. These links hold the path name of the original file. These links contain the path name of the original file. Okay, so inode numbers of these files will be different. Whereas if we establish hard link between 2 different files, the inode numbers of 2 files will be same. Okay. If we establish a soft link, the inode numbers of 2 files will be different. That point you have to remember. Okay. Soft link is a placeholder which points to the contents of another file. This point also you have to remember. Okay. It is a placeholder which points to the contents of another file. Soft link is a placeholder which points to the contents of another file. Okay, so inode numbers will be different and it points to the contents of another file. Okay, soft link can be established by using -s option with ln command. Okay, ln space -s space file name 1 space file name 2. This is the command to establish soft link. S stands for soft link. ln space -s space file name 1 space file name 2. Okay, observe the example. ln space -s space. Here I created 2 files. First one is trial and the second one is inspect. These 2 are the file names. For these 2 files I am going to establish soft link. Okay, by using -s option. ln space -s space trial space inspect. Okay, this command doesn't display any output. This command just establishes soft link between the 2 files, trial and inspect. Okay, we can view the output of this command just by typing ls space hyphen li space trial space inspect. Okay, so by issuing this command only we can check the output of this command. Okay, so observe ls space hyphen li. What is the main importance of this soft link? Okay, here we have to check 2 points. One is inode number and the link information. Similarly, just like in hard links. In hard links, the link information will be 2 and inode numbers will be same. Whereas in soft links, the inode numbers will be different. Observe here, 1375 and 8975. Okay, 2 different inode numbers and the link information is 1. Okay, there is no 2. Okay, whereas if you use hard link, the link information will be 2. It just points to the contents of another file. Okay, so it contains the path name of the original file only. Okay, these 2 points you have to check here by using ls space hyphen li command. By using hyphen s, we can establish soft link. Ln space hyphen s space first file name space second file name. Here also the first file name means existing file name, and this one is new file. Okay, so these 2 points you have to check. Inode numbers different and link information will be 1. Okay, similarly observe here. Here this one is the new file name and trial is the existing file name. Here we have to check this symbol. Okay, arrow. These 3 points we have to check. Here soft link is established. This point we have to check. These 3 points we have to check by issuing ls space hyphen li space trial space inspect. Okay, like this we have to check the link information and inode numbers by using ls space hyphen li command. This command takes 2 file names as arguments. Okay, first one is an existing file and second one is new file name. Okay. Okay, today we discussed about inode structure, link information, how to create hard link and how to create soft link. Okay, after a file is created, kernel allocates a unique identification number, okay, also known as inode number. These inode numbers are used to access an inode structure. Inode structures are maintained in the form of arrays in an inode block in secondary storage area. Okay, next link information. Okay, in order to establish a link, we have to issue a command, ln command. Ln command takes 2 file names as arguments. Okay, ln space first file name space second file name. First file name is nothing but an existing file name and second file name is new file name. Okay, this is about how to create hard link. Okay, ln space first file name space second file name. This command doesn't display any output. In order to view the output of this command, we have to issue ls space hyphen li space file name. If you want to view only the inode number, then you have to issue ls space hyphen I space file name. This command displays only an inode number and file name. In order to view the 8 attributes of a specific file, we have to issue a command ls space hyphen li. Okay, but this command displays the output in 8 column format. In the first column, it is going to display an inode number, whereas in the third column, it is going to display the link information. This is how to establish hard link. Similarly, we can also establish soft link by using ln space hyphen s space first file name space second file name. Here we have to remember 2 points. Inode numbers of 2 files will be different and link information will be 1. These 2 points you have to check in soft link. Okay, today we discussed all these 3 topics: inode structure, hard links and soft links. Thank you.